Hello everybody, welcome back to Mrs. Baker's Chemistry Corner. This is the walkthrough for the Monster paper for Module 5, the paper for Monster paper, and this is question 7. So, copper oxide reacts with dilute hydrochloric acid, and here's the balanced equation for it. You get copper oxide plus hydrochloric acid makes copper chloride, and water. 6 grams of copper oxide were added to 50 centimeters cubed of a 1 mole decimeter cubed hydrochloric acid, and it tells you that there was an excess of copper oxide. Let's go right ahead and look at the questions now, because this introduction hasn't actually said to us, oh, we need to do a table method. So I'm guessing that we may be able to just do a little mini table over on our questions. Let's go and have a look. So the first one, a little bit cut off here, calculate the number of moles of copper oxide added to the hydrochloric acid. Well, for that, we are given the mass and we can work out the MR. So we're in this red mass moles MR triangle. So we can just do mass, mole, and MR. The mass is 6 grams as given to us in the question. And the MR for copper oxide is 64 for copper plus 16 for oxygen. So that will give us 80. So to find the number of moles that we've got, we need to do 6 divide by 80, because it's the mass over the MR, and that gives us 0.075. So we'll just show that we've done 6 over 80 as our workings. Now it's asked us to calculate the number of moles of hydrochloric acid used. So for this, we know that all acids are aqueous solutions, so we're in our aqueous green triangle down at the bottom, the mole, conch, vol triangle. So we can just do mole, conch, and vol. In the question, it tells us we've got a concentration of 1 mole per decimeters cubed, and we've got a volume of 50 centimeters cubed. So for volume, we need to divide by 1,000 to get into decimeters cubed, because triangles only work in decimeters cubed. That gives us 0.05. Concentration is 1 mole per decimeters cubed. So to find the number of moles of hydrochloric acid, I need to do my concentration times my volume. So in this case, I'm going to do 1 times 0.05, which of course gives me 0.05. So I've got 0.05 moles here. Now it's asking me to calculate the mass of copper oxide that did not react. Well, if I look across at my balanced equation, then I can see that I've got a 2-to-1 ratio here. For every 1 mole of copper oxide, I've got 2 moles of hydrochloric acid. So therefore, if I've got 0.05 moles of hydrochloric acid, I've got half the amount of copper oxide, so I need to divide by 2. So I'm going to put 0.05, and I'm going to divide that by 2. That's going to give me 0.025 moles of copper oxide that's been used. This is asking me the amount that did not react, not the amount that did react. So for that, I need to look at how many moles I actually had, which was up here in question part 1, 0.075. And I need to minus off what I actually used, 0.025. That will give me the number of moles that I have left over. Let's do that. So 0.075. I minus off 0.025. That'll give me the number of moles left. 0.05 moles left. Now, it doesn't ask me how many moles. It asked me to calculate the mass. So now I'm back up in this red magic triangle here. I've got the number of moles that didn't react. I've got the MR still, so now I can find the mass. So the next step is to do 0.05 and then times that by the MR, which would be 80, and that will give me 4. So I've got 4 grams left over that didn't react. And that's why it's important to know our molar ratios and things like that, because if this was a industrial process, or you were the owner of the school that was doing this experiment, then that's 4 grams of copper oxide that you didn't need to purchase. So your costs go down for doing this experiment. Okay, next part. Crystals of hydrated copper chloride were obtained from the solution at the end of the reaction. The crystals had the following composition by mass. There was 41.52 of chlorine, 37.43 of copper, 2.34% of hydrogen, and 18.71% of oxygen. Calculate the empirical formula. So we can say it's got chlorine in it, it's got copper in it, it's got hydrogen in it, and it's got oxygen in it. It's got 41.52 over 35.5 because that's the molecular mass. We do 37.43 over 64, which is copper. We do 2.34 over 1, 18.71 over 16. And now we'll do those sums to get our number of moles. So 1.16957. We're going to keep as many decimal places as we possibly can. 0.58484. 2.34 over 1 is obviously 2.34. 18.71 over 16 is 1.1693. So you can see roughly that the chlorine and the oxygen have come up with almost the same number. So they're going to be the same ratio. And our lowest number is 0.58. So now we're just going to divide everything by 0.58484. And that's going to give us chlorine, copper, hydrogen, and oxygen. That's going to give us 1, obviously, for the copper. 1.16957 divided by 0.58484 gives us 1.999999, so that is 2. We don't need to do the oxygen. We could, but it's going to give us 2 because they're virtually the same number. And then we just need to work out the hydrogen, which is 2.34. Divide by 0.58484, and that will give us 4. So we need to come back and say it's told us that this is a hydrated copper chloride. So we know that the copper and the chloride are going to be together. So we've got CuCl2 because we've got 1:2 ratio here. And then we've got 4 hydrogens, 2 oxygens. So we've got to share those out to make water. So a water molecule is H2O. So if this is H and this is O, we've got 2 hydrogens for every 1 water. So that looks like we've got enough to make 2 water molecules. So we're going to say 2H2O. And that way we use up all of our ratio.